Local classes. A local class is a class defined within a method. A local class exists until end of that method or block only. It is hidden from everywhere else, even from the class where it has been defined. So it is the scope of this class is only limited to the method that is enclosing that class. The uses of this class is if a class is needed only inside one method to do a special work and we do not need it to be visible from anywhere else, then we can declare a class as a local class. The rules for local class include: we never declared with an access specifier. Scope is always restricted to the block in which they are declared, so we do not need to specify any access modifier. It cannot be declared with public, protected, private, or static, since it is already understood that it is a class that is local to the method where it has been declared. Cannot include static variables and methods, as was the case with the inner class. Can access the fields of the containing class and the local variables of the method that they are declared in. So we have a outer class and we have a method in that class, and we declare our class inside that method. Accessing methods and fields. Can access the fields of the containing class and the local variables of the method that are declared that the class is declared in. So it can access the members of the class where the method is declared, and the members are local variables of the method where the class has been declared in. So we can have an out class outer 3 with some of its members, static and private, and then we have a method, and we have declared a class inside this method. As we can see, we do not need to specify any access modifier with this class, since this is local to this method. Now if we now this method is inside the local class, and if we want to see what variables we can access, so we can access the variables, for example in this case of the outer class or the containing class, and we can access the variables of the method where the class our local class has been declared. And this is how we can have access to or can run the method. For example, we declare an object of the outer class and we access this method where the class has been declared, and we can see that we are able to print the values for the variables that are declared. For example, in the first case, since the value of x is 10, that is inside this local class, so this will be preferred as over here. The value of y is 10 as well. The value of x for the outer class is 1, so this is where we get the value of x using this statement. And then there is this static variable count, and we are able to access that with the name of the class, that is the name of the outer class. And as you can see, we can print the value for that from within the local class, and similarly we are able to print the values for the local variables as well. Anonymous classes, by definition, a local class that is not given a name but instead is declared implicitly by creating a variable of it. An object to be created using an expression that combines object creation with the declaration of the class. Declare and instantiate a class at the same time. Use them if you need to use a local class only once. So if we need to use the class only once, we do not need to create the class. We can use or create an object of that class as well as declare that class within the same declaration statement, as we will see in the examples. Anonymous classes are commonly used in AWT, as we have been seeing in our examples from our previous lectures, and we were working with the graphical user interfaces programming. The syntax is, for example, we have a class outer, and we can directly, as we can see, declare and create the class. As we can see, this statement, as we have been seeing for declaring objects. So we are declaring the object of the class and declaring the class at the same time. So this is the body of the class, and it is enclosed with the semicolon, and this will also create an object of this class. So this is an anonymous class. If you look at the syntax again, the super type can be an interface that the anonymous class implements, or a class that the anonymous class extends. So it can be anything. It can be an interface that is extended by the anonymous class, since the class itself has no name, or it can be a super class that is extended by the anonymous class that we can use to declare an object and the body of the class. The new statement declares a new anonymous class, as we can see over here, that extends a given class or implements a given interface, and this is mostly used in graphical user interfaces. This creates a new instance of that class with the statement and returns it as the result of the statement, and also creates an object of this. We should note that the class body can define methods but cannot define any constructors. So we cannot have a constructor of this class over here, but we can have methods inside this anonymous class. Local versus the anonymous class, we should remember that anonymous is a local class that is not given a name. Example, hello world interface in case 1 when we are using a local class, and in case 2 where we are using an anonymous class. So we have an interface hello world. It is implemented by the English greeting. As we can see, we have a method, and inside the method we declare an anonymous a local class that implements the hello world interface. This is how we will do it when we use the local class. As we can see, now we can declare an object using this interface of the local class, and we can access the greet method using this object. Now if we look at the local class implements the hello world interface. Now if we look at the anonymous class, this is how an anonymous class will work. As we can see, this is our interface, and we are creating an anonymous class, as we can see, and this is the body of the class, but there is no name for the class we are creating as an object, and this is where it will return and store the class 2 in this object or this variable, and we can then call the greeting method or the greet method of the interface. Create an instance of an anonymous class, as we can see over here, without any name, which implements the hello world interface, and we will implement this hello world interface inside this class without giving it any name. An example of the local, another example of the local class. Local inner classes can be declared anywhere a local variable can be declared and have the same method scope. So the scope of the local class will be the same as a local variable. Local inner classes can only be instantiated from within the method they are declared in. So this is what we need to remember. Local inner classes can only be instantiated from within the method that are declared in. When instantiating a local inner class, the instantiation code must come after the local inner class declaration. So we should only create an object of the local inner class once we have declared the local inner class. For example, we have this method and we have an inner class inside this method, and once we are creating an object of this class, we are instantiating this inner class. We can do that after the declaration of this inner class, and we can access this method that is a method of the hello world class and has been implemented over here by the local inner class. As we can see over here, and we'll get the message. Anonymous inner class, on the other hand, anonymous inner classes, as the terminology implies, have no name. You can't execute the instance of test against anonymous inner classes or any process that requires the name of the class. So we cannot test for an object to see if it is an object of the inner class using the instance of keyword, since the anonymous inner class has no name. Anonymous inner classes can be coded anywhere where an expression is legal, so keep the code to a minimum to maintain readability. Anonymous inner classes can't implement multiple interfaces. For example, we have this method where we are declaring anonymous inner class. As you can see over here, the class will be declared and initialized over here and returned to this variable of this interface, as you can see over here. And once we can then call this method with this variable, and we will get this output. Since we said that it cannot implement multiple interfaces, to work around that, it is simply a less flexible way of creating a local inner class with one instance. So it has only one instance, but if you want a local inner class which implements multiple interfaces, or which implements interfaces while extending some classes other than object, or which specifies its own constructor, you should create a regular named local inner class. Using an interface extending both of them. So we can create an interface if you want to have multiple interfaces. For example, you can create you want to use both of these two interfaces. You can create another interface that extends both of these interfaces, and then you have all of these options as well. But if you want to use an anonymous inner class, then this is the way you can do this. For example, you have these two interfaces that you want to implement, then since and you want to use the inner anonymous inner class, then you can create this new interface that extends these two interfaces, and then you can create the anonymous inner class using this third interface that was implementing the first two interfaces or extending the first two interfaces. So what is the output of the following code? If you go through the code and try to find out what the output of this code would be. To summarize, a static member applies to classes and interfaces. For example, the types of nested classes, the static member classes. Inside a class as declared are declared inside a class as static and can be used by any class. Member classes that are the non-static nested classes apply to classes inside a class as non-declared inside a class as non-static and can be used within the member class. Local nested classes, they are named and apply they can only be classes and declared inside a method and can be used within the method where they are declared. Anonymous, that are local classes without names, applies to classes and are declared inside a method with no name and can be used within the method. The structure of a static member class may have instance or static variables, methods, access only static outer variables and methods. Member or non-static nested classes cannot declare static methods or variables, can access outer instance or static variables or methods, but they can access the static members from the outer class as well as the instance variables. Local or named classes cannot declare static methods or variables, so no static methods or variables are allowed. Can access the outer instance or static variables or methods, and local final variables. Anonymous classes, that are the local unnamed classes, no static methods or variables are allowed and can access outer instance or static variables, methods, and local final variables. So this was our discussion of the nested classes. We'll see a few examples of the nested classes in the next lecture.